All right, let's go ahead and get started with Unit 7, Lesson 3, Powers of 10. So today we're going to be specifically looking at powers of 10. What is the volume of a giant cube that measures 10,000 kilometers on each side? To visualize this, imagine you have a cube and each of these sides measures 10,000 kilometers. Now you're trying to find the volume. And in order to find the volume, we know that's length times width times height. Each of these, since it's a cube, is 10,000. 10,000 times 10,000 times 10,000 is 10,000 to the third power. And if you wanted to write that in expanded form, which we already did up here, in reduced form, that's going to be a really big number. But we can also rewrite this with an exponent of, with a power of 10, and we're going to have 4 zeros here, 4 zeros here, 4 zeros here for a total of 12 zeros. Awesome. 3.2, taking powers of 10. Complete the table to explore patterns in the exponents when raising a power of 10 to a power. You may skip a single box in the table, but if you do, be prepared to explain why you skipped it. I'm looking at this example, 10 to the third squared. I know 10 to the third is 10 times 10 times 10. And I see we have 2 copies here. I think that's what this 2 represents. 2 copies of what? 10 to the third. And sure enough, I count a total of 6 tenths for 10 to the 6th as a single power of 10. There's a 5 right here, and I think that's going to tell me there's going to be 5 groups. 1, 2, 3, 4, 5. Yup, 5 groups of 2, which I know that's math, that's multiplication. A total of 10 tenths. Let me turn off my lights. Oh, okay. Well, this is going to be 10 to the something. I see 1, 2, 3, 4 groups of 3 tenths. If I add all these up together, there's a total of 12 of them. 10 to the 4th, quantity squared. So I know I'm going to need 2 groups because that's the outermost exponent. 10 to the 4th means 10 times 10 times 10 times 10. 10 times 10 times 10 times 10. I know that 4 plus 4 is 8. 10 to the 8th. Yeah, no. I am not going to. Nope, I'm skipping this. Skip card, right? Throwing out the skip card right here. But I can do this for sure. I've been noticing that we're multiplying the exponents up here. 3 times 2 is 6. 2 times 5 is 10. 3 times 4 is 12. 4 times 2 is 8. 8 times 11. 88. Okay, that's not how I draw my eights, but yep, 10 to the 88. Oh, what? I didn't see this. What? Use the patterns you found in the table to rewrite 10m to the n as an equivalent expression with a single exponent. Well, this means we're going to have n of these, and in each little parentheses, there's going to be a 10 to the m. So how many total tens do we have? Well, we have n groups of m, which is multiplication. So we're going to have a total of n times m tens. So I can write this as 10 to the nm. I'm getting a highlighter right now because I really want to, but I'm highlight. See, I actually do mean it. Highlight this thing right here. Whenever you take a power to a power, if you have something like, let's go over here, 10 to the n to the m, you can multiply those, and it equals this little thingy right here. Whoop. Wait, that didn't happen. What? Oh, there we go. If you took the amount of oil consumed in 2 months in 2013 worldwide, you can make a cube of oil that measures 10 to the third powers on each side. It's a lot of oil. How many cubic meters of oil is this? Do you think this would be enough to fill a pond, a lake, or an ocean? Let's answer the first question. How many cubic meters of oil is this? A lot. Do you think this would be enough to fill a pond, a lake, or an ocean? Sure. Why not? Let's look at 3.3. It's more important anyways. Andre and Elena want to write 10 squared times 10 squared times 10 squared with a single exponent. Oh, you know what, actually? How many copies do we have? 3 of them, right? So I know it's going to be something to the third power, and each of these is a 10 squared, so I think that's what it's going to look like. Andre says when you multiply powers with the same base, it just means you add the exponents. So 10 squared times 10 squared times 10 squared is equal to 10 to the 2 plus 2 plus 2, which is equal to 10 to the 6th. I agree. I agree with Andre. That's exactly what we did in lesson 2, the last one. Elena says 10 squared is multiplied by itself 3 times. So 10 squared times 10 squared times 10 squared is equal to 10 squared to the third power, which I agree. That's what we got over here. But she's saying, sorry, they're saying it's 10 to the 2 plus 3. Bruh. Do you agree with either of them? Explain your reasoning. I agree. Sorry, this is collectively. We agree with Andre because, and we know this from the last lesson, 10 to the n times n to the m. What do we do? Whoa, that's a really bad equal sign. We add the exponents. Oh, that didn't work. But anywho, the whole key of this lesson is to understand that whenever you're taking, let's go down here, whenever you're taking an exponent to an exponent, you can multiply them. 4 times 3 is 12. And if you're having issues doing this, expand. There's nothing wrong. I wasn't planning on doing this, but let's do it. Let's look at the homework, okay? Write each expression with a single exponent. And you know what? Just to remind us, I'm going to write this little rule up here so we remember, okay? We can multiply these. 10 to the 7th squared. Well, what's 7 times 2? 14. 9 times 3? 27. You gotta learn your times tables if you can't do it. No, I'm playing. You don't need them. You carry a calculator with you everywhere anyways, aka a cell phone or a pager. 6 times 3? 18. Sorry, I'm zooming in. It's easier for me to write. 10 squared to the third power, 10 to the sixth. Notice how it gets less thick. Okay, I'll stop. Well, 3 times 2 is still 6. 5 times 7 is 35. Right? Because we're multiplying the exponents. You have 1 million number cubes, each measuring 1 inch on a side. If you stack the cubes on top of one another to make an enormous tower, how high would they reach? Well, if this is a cube, here, let me zoom in. If that's a cube, that's another cube, it's another cube. They each measure 1 inch. And how many do I have? Million. So how high would it be? Million times 1 inch equals a million inches tall. That's hella tall. Why do you have that many cubes? Why? Why? If you arrange the cubes on the floor to make a square, would a square fit in your classroom? What would its dimensions be? Explain your reasoning. Okay, I'll be honest, I gotta reread this question. If you arrange the cubes on the floor to make a square, okay, so we're making a square, okay? Would the square fit in your classroom? Well, in order for it to fit in the classroom, I need to know how long each side the square would be. There's 1,000 of these. Sorry, 1,000. A million. Oof, too many zeros. Oh, pues. There's a million of these. And if I think about it, what number times itself would be 1 million? Well, there's 3 zeros here, 3 zeros here. I think 1,000 squared would be equal to 1 million. So this square would have 1,000 cubes on each side. And that makes sense because 1,000 times 1,000 is a million. But I don't have a calculator for this. That's 1,000 inches. And there's 12 inches in 1 foot. So if I divide this by 12, that will tell me how long this square will be. But like I said, I ain't got a calculator. But I can do quick maths. 1,000 and 12 are both even, so I can cut them in half and have 500 over 6. Once again, they're both even, so I can cut those in half and have 250 over 3. That's a little bit more manageable. This will give you 83.3 feet. That's pretty big. I don't think this cube would fit. Sorry, this square would fit in our classroom. How do you turn? There you go. Big oof. If you layered the cubes to make one big cube, what would the dimensions of the cube be? Same idea. You have a million. You want to break this up into 3 equal parts because volume needs length, width, and height. So it would be 100 times itself 3 times. And I know 100 divided by 12, it's a little bit easier to compute. 50 over 6, right, because we're cutting them in half. 25 over 3, that's 8.3 feet. That could definitely fit in the class. A cube that's about 8.3 feet on each side. Oh my god, there's a rainbow outside. Then again, it is raining. An amoeba divides to form two amoebas after 1 hour. 1 hour later, each of the two amoebas divides to form two more. Every hour, each amoeba divides to form two more. I need a table for this. I'm sorry. An amoeba divides to form two amoebas after 1 hour. So here's time. Here's number of, how do you spell amoebas? Amoebas. So after 1 hour, there's two. After 2 hours, each of those will double. So I know there's four. After 3 hours, they will double. There's eight. How many amoebas are there after 2 hours? After 1 hour? Two. How many amoebas are there after 2 hours? Four. Write an expression for the number of amoebas after 6 hours. Well, I know it's going to be doubling, right? I mean, we can actually find this. That's going to be times 2 is 16, times 2 is 32, times 2 is 64. So there's going to be 64 amoebas, but they want an expression. Well, it's 2 to the what power? How many times would we have to multiply 2 by itself? 1, 2, 3, 4, 5. Awkward silence. 6. Whoa, I didn't write. 6. Write an expression for the number of amoebas after 24 hours. Well, it's going to be 2 to the what power? If after 6 hours it's 6, what do you think after 24 hours it'll be? 24. Why might exponential notation be preferable to answer these questions? Because, let me be more proper, because I ain't trying to multiply 2 by itself 24 times. Elena noticed that 9 years ago her cousin Katie was twice as old as Elena was then. Then Elena said, in 4 years I'll be old as Katie is now. If Elena is currently E years old and Katie is K years old, which system of equations match the story? Okay, there's four of these. Well, let's figure this out. Elena noticed 9 years ago. Well, first of all, actually, let me highlight these. Elena is E years old and Katie is K years old. 9 years ago, her cousin Katie was twice as old as Elena was back then. This makes me think Katie was, right? The was makes me think equals twice as old as Elena, 2e, back then, 9 years ago. I'm going to put a plus or minus 9. Then Elena said, in 4 years, I'll be old as Katie is now. This makes me think Elena will be as old as Katie is now. So you gotta take Kate's age and add 4, because in 4 years, she'll be old like Elena. Now, this one has e plus 4 equals k, so it's out of the question. E equals k plus 4. None of these have e. equals k plus 4. Wonderful. At this point, go ahead and take pictures of your work and upload them so you can get credit. But most importantly, write this in your notebook. 10 to the n to the nth power equals 10th to the n m. And if you need an example, it will help. Thank you.